Welcome to Chapter 1, Lesson 1 in IM 3 called Expressions and Formulas. We are going to spend Chapter 1 kind of doing some very quick review of the previous math classes. So a lot of this should look very familiar, and it's not necessarily easy just because it's review. It is going to be kind of quick. They go through quite a bit in this first chapter. So let's go ahead and get started here. So the first part, the notes are always set up in this format. We're going to have main idea or questions on the left, and on the right side, you're going to have an area to fill in notes. Sometimes we will have fill in the blank, and sometimes we will just have some more reading to do or the main concepts over there. So this one says, and we're looking at order of operations specifically for this. So variables are letters used to represent unknown quantities. Expressions that contain at least one variable are called algebraic. Why is my pen not writing? I had it on white, that's why. Algebraic, and I'm writing too big, expressions. So we need a little bit more room there, but you can see it written here. So I know my sloppy handwriting there. So algebraic expressions. You can evaluate an algebraic expression by replacing each variable with a number and then applying the order of operations. The order of operations. So this one's definitely an important one. We've gone over order of operations. I want to say this starts back in 6th or 7th grade. This is definitely one that should be very familiar to us by now. So step 1, we evaluate groupings. And I'm paraphrasing that a little bit from the book. So this is the P in PEMDAS, right? Parentheses. And I'm even going to do this kind of silly with my colors. Parentheses, just so we can see it's the P in our little acronym that we're used to seeing here. So, and then we're going to evaluate all powers. Ooh, I don't know why my E ended up looking like that. Evaluate all powers. So this is the E for exponents. So we say exponents in PEMDAS, but powers, it's the same idea. Remember, a power is just the entire piece. So if I have 2 to the 3rd power, or 2 cubed, this whole thing is a power. This is the base, and this is the exponent. So we can raise it to an exponent, but the entire thing, so remember this is pointing at the 2, the entire thing is called a power. So that's the only difference between those two vocabulary words, just to kind of make that clear. So this is the exponent. And let me go back to red here. Then we have multiply, and or divide from left to right. Oop, not form. From left to right. Program acting funny here. So this is the M and the D part of PEMDAS, right? The multiply or divide part. So multiply or divide. The or is important, and I'm actually going to change that a little bit so you can see or. Over here a little bit bigger. Divide. So it's not multiply and divide, it's and or divide. They say it in here. And remember, you're always going from left to right. So you don't do all multiplication and then all division. You do multiplication and or division together from left to right. So as it comes in the problem, just like you're reading across the page. Let me scooch this up just a little bit here so I can finish this last statement. So let me switch over to red. And the last step is add and or subtract from left to right. Oops. Left to right. So here we have our add or subtract. add or subtract. So again, it's very important. It's not add and then subtract. It's add or subtract from left to right. You're doing it in order. So these two steps go together. All right. So moving forward, we're going to evaluate. I think I scooted this up too high so we can't see this next one. So we're going to go ahead and evaluate some expressions here. And what this means, so this is just practice in plugging in our variable. So they're going to give us values for each variable. So they're telling us A equals -2, B equals 3, and C equals -42. Well, if I know that, then I can replace them. So A equals -2, and I'm going to do this really colorful, just because I feel like it. So A equals -2. So instead of A here, I put -2, and I put it in parentheses to show that I'm multiplying by negative. Remember, parentheses can also mean multiplication. It doesn't always just mean that you have something to simplify necessarily, like in PEMDAS. That's not always what it means. So I'm filling the rest of this in really quick, and I'm going to go to red for B. So I'm going to put in 3. So remember, this is B, and this is A. I'm not very good at drawing them that way, but I tried. So I'm just replacing A with -2 and B with 3 because that's what they told me to do up here. Simply just plugging them in. So I'm going to go back here and I'm just going to start multiplying. I'm not going to do colors anymore because it'll be a little too confusing, I think. So 2 times -2, we get -4 plus, we need to simplify before we apply this exponent. So we have 3 plus 3. And you know what? I'm going to go back actually. All right, order of operations. So we want to do parentheses first. So remember, this parentheses doesn't really mean anything. This is just showing us that it's multiplication with a negative. But we do have to do something about this parentheses. We have to simplify. Because I can say 3 plus 3 is 6. I can simplify that. So anything inside of that parentheses, I have to simplify. And in fact, if we have something like down here, we'll get to where we have more than one set or more than one layer of parentheses, then we have to work our way in. So, and I'll explain that when we get down there. So we'll review that. So now I've done parentheses, and you can even have, I'll even do it off to this side over here. PEMDAS. So you could even have it out and you could go, okay, check, I did my parentheses. And then exponent, so 2, -2, 6 times 6 is 36. Check, I did my exponents. Now we're going to multiply or divide from left to right. So the only one I have is multiplication. So 2 times -2 is -4 plus 36. So check. And then add or subtract. So I have -4 plus 36. Remember, that means since they're opposites, I'm going to subtract. The bigger number, which is 36 in this case, decides the sign. So I have more positives than negatives, right? So positive 32. I took the 4 away from 36. All right, so there it is. We evaluated that expression. It's down to 32. All right, let's keep moving here. So this next one, let's see if I can kind of fill this in a little bit. So I have an exponent of 2 plus 4 over 3 plus 2. All right, the rest of it's going to have some colors on it. So A, which I decided was blue up here, is -2, and I'm going to put that in parentheses because it's not, A is -2. So I don't just, if I don't put the parentheses here, what it means is I'm only squaring the 2, the negative's just out in front. But if I put the parentheses there, it means I'm squaring the negative also, so it's included. So just be aware of that. And then we also have, whoops, I'll switch it to red. We also have a B, so I'm going to put not -3, just 3. And now we're also adding in, let's see, what color do we want to do? I'll do pink, why not? Oh, that just looks red. Let's see, green? All right, green. So we'll do green for C, and that's 4.2. Just realized I forgot to do this, which not a big deal here. It's just my fun color coding so we can kind of connect it. We can see very easily what's going on. Probably not going to do the color coding for these two. I'm just showing you kind of connecting this so that we can quickly see. I'm just plugging in the numbers they're asking me to plug in. All right, so parentheses first. Again, all of these parentheses are just to show multiplication. So that's not what we're talking about when we do the check mark here. We want to make sure that we're kind of clear on that one, is that the parentheses mean that there's something to do. There's some operation to simplify, like 3 plus 3. All right, so exponents would be the first piece. So we have -2 squared. So remember that's -2 times -2, positive 4, plus 4 times 4, 2, 3 times 3, plus 2 times -2. All right, it's kind of a pretty blue. I've never used that one before. I think it's called cobalt blue. All right, so now we did our exponents. We didn't have any parentheses, so we're going to do multiplication or division. 4 plus, and we have 4 times 4.2. So let's see, we end up with 8 and 16. And the bottom we have 3 times 3. And then we have 2 times -2, which is -4. Okay, so now we can do our addition or subtraction first. I know we have a division problem here because I have a fraction, but I need to simplify the numerator and the denominator before I attempt that division, because it would definitely get very confusing if we tried to deal with this right now. So we're going to simplify this, and then we'll deal with the division. So 4 plus 16.8, and I'm going to write that up here, 20.8, over 9 plus -4. Remember, they're opposites, so I subtract. 9 is bigger, and it's positive, so 5 is definitely positive. So now we can divide this, okay? Now we can go 20.8, and we can divide by 5. So we get 4.16. So that is our evaluated expression, down to 4.16. And this makes sense, you know. Normally I'd be a little wary of decimals in the answer, kind of first section here, but we are in IM 3, and they did give us a decimal to plug in, so that makes sense, that we would potentially have a decimal come out here. As long as you check your math, you can always go back and make sure, did I actually plug everything in correctly, to find the correct answer there. All right, so I'm not going to worry about color coding down here. I'm just going to start plugging some numbers in so we can finish this guy up. So we have 5 times C, which is 4.2, minus 2 times the quantity of the difference of B minus A, or B and A. So we have 3 minus -2 plus C, parentheses. Okay, so this is where we have to start dealing with the multiple layers of parentheses. And one thing too I want to point out, I'm going kind of painstakingly slow on these steps. And I know I have students even, you know, in IM 1 and IM 2 that don't necessarily like this very slow one piece at a time. I'm doing it this way so that you can very clearly see I'm doing the order of operations each time. But we definitely want, you know, to follow the order, but could I have gone a little out of order on this one? And I could have done the exponent and the multiplication kind of at the same time? Yes, you can. You just want to make sure that you're paying attention to what you're doing, because you don't want to do an addition or a multiplication before you've applied the exponent. Say if something was also being multiplied on the front of this, or something along those lines. Well, I wouldn't be able to do this multiplication before I applied the exponent. Or I can't add 4 plus 4 before I multiply these. So you just need to be careful. The order of operations is always present, but you don't necessarily have to do it each piece at a time. You can kind of combine steps, especially at this level of math. All right, so we're going to do this first piece here, and I'm still going to do it in the order just so that we stay consistent. So we're going to deal with parentheses first. And when we have two layers of parentheses, what it means is we have to start over inside of the parentheses. So I'm going to simplify the parentheses here. And I know I kind of keep adding more check marks, and that's going to erase a little bit of my stuff there. But inside of the parentheses, I have to go back to the top of the list, which is parentheses, and I'm going to start over again. So that means I have to simplify this parenthesis first. So it's 3 minus negative 2, which I forgot to put the extra parenthesis there too, because I put negative 2 around. I added a third layer myself. So two negatives make a positive here, and I would actually have 5 because I would add them together. Plus 4.2. Now, do I need these parentheses anymore? No, I do not. I can get rid of these, and I'm going to erase the whole thing here, and just go 5. Because now I've dropped down to a single number. It's positive. I don't need to have parentheses around it. You don't necessarily need, if it was a negative 5, you wouldn't necessarily have to put the parentheses around it either. But it's definitely a good way to indicate that, they're kind of together. So 5. All right. So let's keep going. 4.2. Actually, sorry. Messing up my order here, aren't I? Because now I've done partially the parentheses. I've done the first set of parentheses. Now I'm going to do the second one, which is the brackets. So 4.2 minus 2 times, and I'm just going to bring them down to kind of the regular looking parentheses, and I just want to add these guys together. So I get 9.2. Now I can do exponents if I have them. Well, I don't, so I'm going to skip down and do multiplication or division. Definitely have some multiplication or division, so now I can do 4.2 times 5, or 5 times 4.2. It doesn't really matter which way I say that. So I get 21 minus 9.2 times 2, and I get 18.4. So I've done multiplication or division, and now I can just subtract. So I can say 21 minus 18.4. So this one, they are opposites, but it's usually a little more obvious in this case that we are subtracting because it's set up like a subtraction problem. So we get 2.6. All right, last one. We have 4 times 2 times negative 2 plus 3 times 3 minus 2 times 4.2. So usually with this one, I should probably change these to brackets since I added some extras in here so that it's very clear that it's kind of its own layer, the whole thing, and it doesn't get mixed up with these guys in here. So parentheses first, we're going to go inside of here and we're going to simplify this down to one number. So 2 times negative 2 is negative 4. 3 times 3 is 9. Minus 2 times 4.2. And now we have negative 4 plus 9, negative, positive, so I subtract. 9's bigger, so it's positive 5. All right, so we've dealt with our parentheses here. I've got way too many decimals on that side. And now we can multiply or divide, so I dealt with parentheses again. We don't have any exponents, so I'm going to go to multiply or divide. Oh, I forgot to put a check mark for the last one. 20 minus, so 4.2 times 2, and we get 8.4. And now we can add or subtract. So 20 minus 8.4, we get 11.6. So multiply, divide, add, subtract. I did all of my pieces there. So we have our evaluated answers. All right, let's go to the next page here. So we have a formula is, we're going to write out a sentence here, a mathematical sentence that expresses the relationship between certain quantities. So it's just certain quantities that already have a relationship, and it's a mathematical sentence that helps us express this. If you know the value of every variable in the formula except one, you can find the value of the remaining variable. So some examples of variables would be area of a triangle, so area of a, and I'll put triangle. Whoop. Angle. So this is area. Area of a triangle, I don't know, I'm losing my mind, of a triangle. And we would have 1/2 times base times height, which just, if we actually look at a triangle like this, we'd have the height is perpendicular to the base. So my base is the entire thing here, the whole bottom, and this is my height. If I have a right triangle like this, then the base would be the bottom, and the height would be the length kind of going up. So it's the two pieces that come together at a 90. So at a right triangle, it's just the two sides. If it's not a right triangle, then we need the height going from one vertex to the other side at a 90-degree angle. So it needs to be perpendicular to the other side. All right, so that's just showing you kind of a visual of that one. Another one could be, say, the volume of a cone, right? So that would be V equals 1/3 pi r squared h. So what this means is if I have a cone, I'm going to try to draw a cone nicely. It's not my best suit here. It's a very horrible cone. We're going to pretend like this is an upside down ice cream cone. So we have a height going down. So this would be our height. The radius would be this piece here going from the perpendicular intersection of the height and the base and over to the side. So this is called the radius, which is what R stands for. Radius, and we just pay attention to that. Height, and then this is pi, which is 3.14 is the short way to do that, but definitely we use a calculator a lot of the time for these pieces, or they'll tell us to use round it to 3.14 or even use a fraction sometimes. And IM3, I'm not sure how often we actually use the fraction form, but it may come up. But these are just a couple examples of formulas. So let's go to the next screen here, and we are going to look at a formula that they give us. Okay. A player's attack percentage, A, is calculated using the formula A equals K minus E divided by T, where K represents the number of kills. So this is kills. E represents the number of attack errors. So this is errors. And T represents the total attacks attempted. So I'm just going to write attempted, but it's T for total, right? So these are the attempted attacks. So this is just a formula to put this together. As far as these numbers have this relationship to each other. And if we understand, if they give us some of the pieces here, which down below we can see already, that they're going to give us 3 of the 4 variables, then we can solve for the fourth missing variable. Sometimes it will be the total. In this case, that's what we're looking for. But sometimes they will give you the total, and they want you to find one of these other missing variables. So it just depends on where they place that, or which values they give us here. So we're going to find the attack percentage given each set of variables. So we have A equals, and it's K minus E, so 22 minus 11, because K is 22, E is 11, divided by T, which is 35. So I have A equals 22 minus 11 is 11 over 35. And in this case, it kind of depends on what Alex is looking for. If it hasn't asked me to round, I would probably leave it 11 over 35 to make sure that I don't round incorrectly. But if it asks me to round to, say, the nearest tenth or the nearest hundredth, then, that tells me that I'm having a decimal and I should round it. But since there are no instructions on rounding, I would leave it the fraction, 11 out of 35. Just It is a percentage, though, so actually I might have to redact my statement there. Since it is a percentage, we do want to do 11 divided by 35. So I should have thought that through before I said it, but that's okay. I thought about it afterward. So it's 0.31428. It just keeps on going. I'll round that up, 6. So I'm just going to go ahead and cut it off at 1,000th there so that we have some kind of cutoff. Usually Alex will tell you what it wants you to round it to, either a whole percentage or something along those lines, or a tenth or a hundredth, thousandth, whatever. So remember, we need to move this decimal twice for percentage. So A would equal 31.4%. All right, let's do the second one. A equals K minus E divided by T. So A equals 33 minus 9, and we get 24, divided by 50. So let's see, 24 divided by 50, and we get 0.48. So this one's definitely easy. I don't have to do any rounding at all. It was terminating. So I just need to move my decimal 2 times. So A equals 48%. So that was section 1, and I will see you in section 2.